back. Today's goal of this lecture. At first, today I will see one question which had come in GATE exam and which depends on actually center of a group. We all of us know this concept. Today at first I will see one question of GATE exam which actually come in recently exam, GATE exam 2023. Then I will see the structure of subgroup of S4 group. And this type of structure, if you know, then you can understand how will be the subgroup of SN group. You can understand it easily. First question is let GL2, here the field is complex number. Denote the group of 2 cross 2 invertible complex matrices with matrix multiplication. And for two matrices S and 2 which belongs to GL2 C, where C be the field, then the cyclic subgroup generated by S and T, who is denoted by actually the subgroup generated by S and T, where S is the 2 cross 2 matrix which is look like 0 minus 1 1 0, and obviously this is member of GL2C, and G1 G2 G3 be the two subgroup which is generated by GL2C and given by here T is in the question has given in different way T1 T2 T3, and the first structure is G1 equal to cyclic subgroup generated by S comma T1, where T1 equal to set of 2 cross 2 matrices I0 0 I. G2 equal to cyclic subgroup generated by S1 comma T2, where T2 equal to the set of 2 cross 2 matrices I0 0 minus 1 minus I. G3 equal to cyclic subgroup generated by S comma T3, where T3 equal to 0 1 1 0. And consider the center denoted as ZGI, denote the center of GI, where obviously I equal to 1 2 3 so on. First option G1 is isomorphic to G3. Second option ZG1 is isomorphic to ZG2. Third option ZG3 equal to the set containing the element only identity matrix. Fourth option ZG2 is isomorphic to ZG3. Now notice the first option, G1 is isomorphic to G3. Here G1 means obviously the set generated by ST1. Notice here S equal to given S equal to this matrix, then S square equal to minus identity and S to the power 4 equal to identity, and given T1 equal to this matrix. And notice here very interesting thing, T1 equal to I times identity, T1 square equal to minus identity, T1 to the power cube equal to minus I to the power identity, and T1 to the power 4 equal to identity. That means G1 which is generated by ST1, this order would be 8. And notice here one thing very noticeable, T1 equal to I times identity. That means this is scalar matrix obviously. So any scalar matrix always commute with any other matrix of same order. So obviously G would be abelian group. The question has indicated G1 is isomorphic to G3. This is very interesting. G3 means this is generating by the set ST3. And notice here T3 is just involutory matrix. That means T3 whole square would be identity. Here order of S is order 4 and order of T3 is 2 order. That means this is very interesting. One element of order 4 and other element is order 2. That means this G3 is actually isomorphic to D4 group. We all of us know D4 group contain 4 order element which is reflection and 2 order element which is rotation. In this G3 which is generated by T3 which is actually such type S comma T3 such that S to the power 4 equal to identity and T3 square equal to identity and T3 is equal to, in D4 we all of us know this is equal to T3, sorry here T3 not TQ, T3 is equal to T3 is inverse. That means this is actually isomorphic to D4 group and obviously D4 group is non-abelian group. So G1 is isomorphic to G3. This is cannot possible because this is one abelian group and this is one non-abelian group. So option 1 wrong option. G1 cannot be isomorphic to G3. 1 is a wrong option and option 2 indicate ZG1 is isomorphic to ZG2. Here noticed since G1 is abelian group, that means ZG1 would be whole group. Now G2 which is generated by S comma T2, then if we commute S with T2, then this value would be minus T2S. So this cannot commute each other. So obviously this is not abelian. So option 2 also wrong option. ZG1 is isomorphic to ZG2. This is also wrong option. And option 3 indicate ZG3 contain only identity matrix. This is also wrong option because G3 is isomorphic to D4 group and center of D4 group we all of us know this is contain always 2 element. So only identity, this is not possible. 3 also wrong option and option 4 indicate ZG2 is isomorphic to ZG3. This is obviously right option. Big question, why 4th option is a right option? Because I have got G3 is isomorphic to D4 which is obviously non-abelian and we all of us know the center of D4 is 2 element. Here the question ZG2 is isomorphic to ZG3. G2 is this group and I have got ST2 not commute with minus T2S. So obviously this is non-abelian group. That means G2 and G3 both non-abelian group. Here the question about ZG2 and isomorphic to ZG3. Since G2 is generated by ST2, here if we consider ST2S, then we can write this as S times minus ST2 which is actually equal to minus S square T2. So the element are here look like S to the power I, T to the power I, and this is such type S, S square, S cube, identity, T square, T cube, comma ST. which is actually isomorphic to quaternium group Q4, which is non-abelian group. I hope my all viewers have understood this process easily. So, obviously, ZQ4, center of quaternium group is only contain 1 and -1. So, since ZD4 also contain 2 elements and ZQ4 also contain 2 elements and both group is non-abelian, so we can tell ZQ4 is isomorphic to ZD4. I hope my all viewers have understood this process, why this is true, why third option is true. Okay, now I will say our next goal of this lecture. I will see how look like the subgroup of Sn. As an example, I will see the subgroup of S4 group. All of us know this is the structure of S4 group. This is 2 cycle, 1, 1, 2, 1, 3, 1, 4, 2, 3, 2, 4, 3, 4. And another 2 cycle would be such type 1, 2, 3, 4, 1, 3, 2, 4, 1, 4, 2, 3. And 3 cycle look like here in S4 1, 2, 3, 1, 3, 2. 2, 3, 4, 2, 4, 3, 3, 4, 1, 3, 1, 4, 4, 1, 2, 4, 2, 1. S4, the 4 cycle is look like 1, 2, 3, 4. And the inverse of 1, 2, 3, 4 is 1, 2, 4, 3. 1, 3, 2, 4. And inverse of 1, 3, 2, 4 is 1, 3, 4, 2. 1, 4, 2, 3 and inverse of 1, 4, 2, 3 is 1, 4, 3, 2. This is the structure of S4 group. We all of us know this type of structure. Then I will say the subgroup of S4 group. The subgroup of S4 is such type D3, D4, Z3, Z4, Helen4 group, which is isomorphic to D2 and A4. At first I will construct the subgroup Z3 because other subgroup of S4 will be constructed by Z3. So at first I will construct the how look like the subgroup of Z3 in S4. At first we all of us know the element of Z3 is look like 0, 1, 2, where order of 1 is 3 and order of 2 is also 3. So in S4 the subgroup structure which is isomorphic to Z3 would be such type identity 1, 2, 3 and inverse of 1, 2, 3 obviously 1, 3, 2. And notice here in S4 there exist 4 elements of order 3. So I can construct 4 subgroup of order 3 which is actually isomorphic to Z3. And the subgroup is look like, that means other subgroup would be such type identity 2, 3, 4, 2, 4, 3, identity 3, 4, 1, 3, 1, 4, identity 4, 1, 2, 4, 2, 1. Okay, is 4 subgroup which is isomorphic to Z3. Okay, OL. Structure of D3 is such type. Here we all of us know in D3 there exists 2 variables, rotation and reflection, and this is called as rotation which is actually isomorphic to Z3. Since here the D3, here alpha square alpha cube, this is isomorphic to Z3 and this is the rotation and this is reflection beta alpha square beta. So here D3 would be such type. Here the rotation, at first rotation. At first look the element of Z3 0, 1, 2 and order of element of Z3 this is 1. Z3 order of 1 is 3. In Z3 order of 2 is also 3 and rotation means this is isomorphic to Z3. So this would be such type identity. Here the element of order 3. So 1, 2, 3, and the inverse of 2, actually the inverse of 1 here. So inverse of 1, 2, 3 would be 1, 3, 2, and other is reflection, and we all of us know the order of reflection here 2. So here since 1, 2, 3 and 1, 3, 2, so reflection element would be, consider this type of element. Here 1, 2, 3, 4. I cannot choose this element because here contain 4. But notice the rotation here 1, 2, 3, 1, 3, 2. So if we choose this cycle, then it would be the image of 4 would be different. So we cannot change this part. So here would be such type of cycle in which 4 does not contain. Such type of 2 cycle in which 4 does not contain. Because otherwise the image of 4 would be different. So here we can choose 1, 2, 1, 3, 2, 3. Have you understood? And other subgroup of D3 would be such type. There exist 4 distinct 3 cycle. So we can construct actually 4 subgroup which is D3. Then other subgroup of D3 would be such type identity 2, 3, 4. And inverse of 2, 3, 4 is 2, 4, 3. And notice here one thing is very noticeable. In 3 cycle 1 is fixed. So from 2 cycle in S4 we cannot choose this type of cycle because here in this cycle 1 element content. And if we choose this cycle, then the image of 1 would be different. So we cannot choose this type of cycle. We can choose obviously this type of cycle. So consider 2, 3, 2, 4 and 3, 4. This would be other type of subgroup of D3, and other subgroup of D3 would be such type identity 3, 4, 1. Here the inverse of 3, 4, 1 is obviously 3, 1, 4. And since here the element 2 is fixed in the 3 cycle, so we cannot choose such type of 2 cycle in which the element 2 is content. So obviously we can choose 1, 3, 1, 4, 3, 4. This would be other subgroup of D3. And notice another subgroup of D3 would be such type identity 4, 1, 2. And here the inverse of 4, 1, 2 obviously 4, 2, 1. And since here the element 3 is fixed, so obviously the cycle would be such type 1, 3, 1, 4, 2, 4. Because in the 3 cycle the 3 element is fixed. So we cannot choose 3 in 2 cycle. Have you understood? All viewers have understood how would be the subgroup structure of D3 in the group S4. Subgroup is D4 group. Who is this? We all of us know. Here the rotation is isomorphic to Z4. So and other is reflection, who is order is 2. So the subgroup would be such type. We all of us know the subgroup of Z4 in S4 is 3 distinct subgroup. So there exists 3 distinct subgroup which is D4, and the structure of the subgroup is Z4 at first Z4 types. E 1 2 3 4 1 4 3 2, and we all of us know in Z4 this 2 cycle would be such type: 1 goes to 3, 2 goes to 4, 1 3 2 4. Then this would be here 1 3 2 4. Then just break it pairwise: 1 3 comma 2 4. Other would be 1 2 3 4 and 1 4 3 2. This is one subgroup which is D4. Another subgroup is identity 1 3 2 4. The inverse image of 1 3 2 4 is 1 4 2 3, and other is 1 goes to 2, 3 goes to 4. That means 1 2 3 4. Here also here 1 2 3 4. Now break 1 2 comma 3 4. Write it as 1 3 comma 2 4, 1 3 2 4 and 1 4 2 3. And this is another subgroup which is isomorphic to D4. And other subgroup is identity 1 2 4 3, 1 3 4 2, 1 goes to 4, 2 goes to 3. Now break it pairwise: 1 4 comma 2 3, and then this would be 1 2 4 3, 1 2 4 3. And other subgroup, other element of D4 would be 1 3 4 2. I hope my all viewers have understood how look like the subgroup of D4 in S4. Then other subgroup would be K4. This is very easy type subgroup. And the Killen4 group, this subgroup in S4 would be such type. We all of us know in Killen4 group there exist 3 elements of order 2. That means K4 would be such type: identity 1 2 3 4, and other cycle would be 1 2 3 4. This is one subgroup which is isomorphic to K4. Other would be identity 1 3 1 4, then 1 3 comma 1 4. Then other would be sorry here 1 3 not 1 3 comma 2 4. Then other would be 1 3 2 4. Okay. And another subgroup would be identity 1 4 comma 2 3, and other would be 1 4 2 3. There exist 3 subgroup of order 2 which is isomorphic to K4 in S4. Other subgroup is A4, and we all of us know A4 means just even permutation. This would be identity, this type of cycle, and other 3 cycle would be all even contain the even permutation. So A4 contain the element identity 1 2 3 4, 1 3 2 4, 1 4 2 3, and other 3 cycle. Obviously this is even permutation: 1 2 3, 1 3 2, 2 3 4, 2 4 3, 3 4 1, 3 1 4, 4 1 2 4 2 1. Okay. This is the structure of A4 in S4, and obviously this type of subgroup in S4 only one. I hope my all viewers have understood the structure of subgroup in S4. If you can to understand in the subgroup of S4 in better way, then you will understand all type of structure of subgroup in SN. Okay? I will stop here. In my next video, I will discuss many questions about this topic. Okay? See you soon. Stay safe and stay positive always. And don't forget to subscribe my channel for more videos. Thank you so much.